हाय सर। हेलो। एम आई ऑडिबल? Hello everyone, Jai Hind and good morning. Am I audible to everyone? Just give me a thumbs up and let me know that I am audible and you are seeing the screen. You can see everything on the screen that is there. All right. So today we'll be talking about geography. All right, we will be starting with the geography as a subject, and as in my orientation lecture that I have conducted and it is available, I told you that geography as a subject is very important when you are going for the either prelims or the mains. Geography is very important subject, and geography as a whole is a conceptual subject as well. So today we'll be talking about geography, a complete introduction about how we'll be taking the sessions, what all things we'll be covering in the upcoming sessions, and as well as we'll be talking about, universe and the solar system. That is our first chapter that we'll be talking in today's session. All right. And if you have any doubt, you can, in the class also, you can unmute yourself either and then let me know whatever doubts you have, whatever things that you want to ask, or you can write down in the chat box as well. There is a chat box, you can write in the chat box as well, and let me know that if you have any kind of doubts. All right, am I clear? Audible to everyone? Am I clear? All right. So let's start with the session, and we'll be talking about geography as an introduction. And when I'm talking about geography, geography as a subject. Initially, man is a curious animal, right? There are lots of curiosity that happens in the mind of human beings, and we are always curious about different things which are happening around us. So what happened was initially, the curiosity was about, how everything started, or we can say how everything, dating from the origin of the universe and up till now, how everything started and how everything was arranged, and that led to the formation of history as a subject. All right, so it was history that was, history was there. History as a subject, it emerged. Then there were the social aspects were studied. How the human beings are, they are interacting with the environment, they are interacting with the earth, and how it is happening. So that led to the again it led to the establishment of another social science, and that is sociology. All right, the interaction between the society, how the society is interacting with the environment, and ultimately, how this earth and universe it started, it emerged, and it developed, that led to the emergence of geography. Now, when geography as a subject was introduced, what happened was, as a curious mind, the people that were there, all right. So what happened was, because of the curious mind that was there, it led to what it led to? It led to the age of exploration. It led to age of exploration. And when I'm talking about age of exploration, what happened was that cartography, what is cartography? When you talk about cartography, what is cartography? Who will tell me? Have you heard about this word cartography? Yes. When we are talking about cartography, what is cartography? It is very good. Art of map making, or you can say that it is, projecting the Earth's surface on the map, or map making is known as the cartography. So initially, when we are talking about geography, what started was, it was age of exploration. And when we are talking about the age of exploration, what happened was, during the age of exploration, there were various expeditions that were taken, and later on those were projected on the maps. The cartography started, and then the geographers, or you can say the explorers which were there, their main objective was to project the earth on the surface of the maps, or the cartography it developed. And when cartography developed, later on, slowly and slowly, different branches of the geography they emerged. When we talk about geography, what is actually geography? What is actually geography? How can we say that what is a geography? Geography is made up of two different subjects. It is geography, geo plus graphos. All right, it is geo plus graphos. That is the study of the earth. You can say in the simple words, the study of the earth, or you can say that it is writing about the earth that we can consider as the geography. That is called as geography. So it is made up of two words that are there. Now, when we talk about geography, all right, as a subject, when we talk about geography, when we learn about geography, what all do we study? We study the variations which are there on the surface of the earth. That is the physical features that we see. All right, whether it is the rivers, it is the mountains, it is the plateaus or the plains. We see all those different types of variations on the earth's structure, and that is what we call as the physical features, because those features we can see, we can touch. All right, you can touch a mountain, you can go and you can climb up a mountain because it is a physical feature that is there. All right, and there are different variations in the, because of the various physical features that are there, you will find that the societal interactions are very different. If you are living in the hilly regions, the society, the framework, it will be completely different. And when you go to the plains, the societal framework is different. The economy is different. People in the hilly regions, they won't be practicing agriculture on an intensive scale. But when you go to the plains, you will find that the people are practicing agriculture, in plains which are near to the river fields, the river beds. So there you will find that the people are involved in what kind of economic activity? They will be majorly involved in agriculture and the allied activities. So the societal arrangements are different when we talk about the different physical features that led to the formation of the social geography. All right. So we have the social geography that was, again, it was influenced because of the different physical features that are there. And that resulted into different economic activities. Again, economic geography, which is again a sub branch of the geography that we'll be talking in our further upcoming sessions. The first thing that we'll be talking about is the physical geography. How the physical geography has been established, or what all features we see, and what all the major theories of development of the physical features are there. Like the most important one is the plate tectonics theory that we'll be studying in our upcoming sessions. All right. Now, coming to the important thing that is there. The geography as a term, it was coined initially by Aristophanes, and Aristophanes is aptly called as the father of the geography. So we have another name and we can call him Aristophanes, who is the father. He also measured the circumference of the earth. All right, he was the one person who measured the circumference of the earth. So when we talk about the geography, so how geography came into being. So geography is basically, when we are talking about, it is a combination of two Greek words, just like I said. It is graphos and geo. That is the writings about the earth. Or when we talk about the geography, it is all about the earth, the formation of the earth, the formation of the universe, the stars, the solar system. Everything is it is encompassed into the geography as a subject. Now, like I said, that the geography was, as a term, it was coined by Aristophanes. Aristophanes is also known as father of geography. He is called as father of geography. Now, such type of questions you can find in your exams, but most probably in your PCS exams. All right, if you are appearing for the state Public Service Commission exam, there you can find such kind of direct questions. Who is the father of geography? But usually now UPSC do not ask any direct questions. UPSC is more concerned about your conceptual knowledge. That is very, very important. And when I say conceptual knowledge, geography has to be understood with the concepts that you have to understand. All right. Another thing that I want to convey to you is that today we are taking this session without the smart board, but in the future we'll have the smart board that will be installed in the next upcoming sessions. In next 4 or 5 sessions, we'll have the smart board that will be installed. The smart board is already here, but due to certain difficulties, as I am right now in a hilly region, I'm in Himachal Pradesh, let me tell you, and for those who do not know me, my name is Bhavar Singh Suroi. I'm XND 115th course. I qualified UPSC IS in 2012, and with geography as my optional subject, and that is why I take geography as my subject. I'm very enthusiastic about geography, the different features, and that is why right now I'm there in Himachal. So I thought that I will shift my everything, my setup to Himachal, and I will have a complete setup here. But because of the hilly region, the terrain, here we do not have the fibers. All right, we do not have the fiber optics, and initially there was, but now BSNL is also not providing. So what I'll be doing is I'll be again shifting to plains, that is in Meerut, that is my hometown. So I'll be shifting there. I'll be shifting my complete setup there, and then we'll be taking the sessions on smart board. So that will be more interactive. But today, because we are already late, we had to start the sessions from 15th or 16th. But because of all the issues that we are facing right now here because of the installation, so the classes got postponed, and then we thought that we will not postpone the classes more. We'll have this session on the on the screen, that is on the laptop, and with the help of the pen tablet. And later on, after the board will be installed, we will be shifting to the smart board. All right. I hope that you all can, just bear with me for next 4-5 classes. All right. So Aristophanes, like I said, you will find such kind of questions in direct questions in your PCS examinations. If you are appearing for UP PCS, MP PCS, or for Rajasthan, for any other PCS examinations, you will find such kind of direct questions that would be asked. But now UPSC will not ask any direct questions. It may ask, but the chances are very rare. If you'll see the last previous year questions, so you'll find that the direct questions are very limited. All right, so the geography as a term was coined by a Greek geographer that was there. Aristophanes, he was also known as the father of geography. And when we talk about the geography, it is the writing about the earth. Now, what about the earth? The various land, the features, the different type of features that we see, we see the different kind of topographies that are there, inhabitants are there, and also the phenomena that happens on the earth, whether it is on the earth, above the earth, or inside the earth's surface. When we talk about the earthquake and volcanoes, we talk about the process that is happening inside the earth. All right. When we talk about weathering and erosion, the shaping of the earth, the various relief features which have been created because of the external processes, we talk about the process or the phenomena that happens on the surface of the earth. So that is how we study geography. Now we have two major subdivisions when you talk about geography. The first major subdivision is the human geography, or it is concerned about the social science, how as a human we are interacting with our complete environment. And then there is physical or the natural science. When we talk about physical geography, you will find and you will be amused that there are various scientific concepts which we will be studying, and with the help of those scientific subjects, we'll be understanding how our complete physical geography has been shaped. All right. So whether it is the convective currents, all right, the convective currents, we'll be talking about the convectional current theory, and we'll be talking about, the various physical laws which have been established, how they are, prominent in shaping our earth, the shaping of the earth's surface, the sphere, the complete shape of the earth. So that is basically what we study in the physical geography. Now, it was Ptolemy, Ptolemy and Eratosthenes, they are the prominent. Ptolemy was also a very great cartographer, all right, and he wrote Guide to Geography. This is one of the book that is wrote in 2nd century in CE, and he defined geography as representation in pictures of the whole known world together with the phenomena which is contained therein. That means representation in pictures means what? It is the mapping. So he was talking, because that time it was the age of exploration. All right. So they were making, you must have seen various movies, So it was an age of making maps. There were various maps which were made at this point of time, and there were various explorations that were conducted, and therefore at this point of time geography was confined to representation in pictures. Majorly cartography was focused during the period of age of explorations. All right. Now when we talk about, just a second. Now, when we talk about geography, today geography, you can correlate geography with various other subjects. Or you can say that the geography as a whole is an interdisciplinary approach. It is an interdisciplinary approach, or it is very closely related to various natural sciences, whether it is geology, whether it is pedology, whether it is bio or botany and zoology, ecology, environmental science. So when we study geography, geography as a subject is an interdisciplinary approach. And that is what I want inside you also. If you are aspiring to be an administrator, if you aspire to clear UPSC, let me be very frank. You have to, I always say this to my students. All right, my student asks for, sir, what is the Guru Mantra? All right, the one mantra that you want to give to the student so that they can qualify UPSC. So I always say that the Guru Mantra for qualifying UPSC is that you have to widen your horizon. You do not have to think only in a limited sphere. You have to widen the horizon, and for interdisciplinary approach, geography is the best kind of subject, I will say. Like for example, when we talk about geography, we learn about geomorphology. Geomorphology, again, it is composed of two different words. Geo means earth and morphology. Morph means the shape or the size. So when we are talking about geomorphology, geomorphology is basically concerned about what? It is concerned about the you can say it is concerned about the different shape, size and the features, relief structures which are there. And geomorphology is closely linked to geology, because in geology we study how the earth originated. All right, the structure, the rock structure. So the rock structure will define the shape and size of any of the physical feature that will be produced, or the relief structure that will be there. So ultimately, geomorphology is closely linked to geology. In the same way, climatology, we study climatology as part of geography. Climatology as a branch is related to meteorology, because whatever happens in the climate, it is because of the various phenomena that we see in the atmosphere. All right, whether it is humidity, whether it is the wind velocity, whether it is the precipitation, everything is linked, and it gives us the branch of the geography that we call as climatology. Then comes oceanography. In oceanography, we study the relief structure of the oceans. We study the various phenomena, like we study the waves, we study the tides, we study the the ocean currents which are there. We study the various aspects of the oceans in the oceanography, like the various kind of animals which are there, we find in the oceans. Now, as a branch, we study in the geography oceanography, but as a separate subject, it is closely related to hydrology. Then soil geography. In the soil geography, how the soil is formed, the soil horizons, and again, it is linked to pedology. All right, the science of the soil. Then phytogeography. Phyto means plants. So anything that is related to plants, when we are studying the different type of species, we correlate. There is a different type of climate that would be found in the equatorial region. So in the equatorial region, you will find mahogany and ebony trees. All right, you will find rubber trees, but the same trees you will not find in the conifer belt. In the conifer belt, where the temperature is less, you will find there the conifer trees. Like you will find the spruce, you will find fir, and also you will find devdar and pine forest that will be there. So when we are studying the plants, the species, that becomes phytogeography, but at the same time, that is then again it is a part of a broader subject, that is botany. In the same manner, we have different species which live or which are closely related to the geography or geographical aspects of the region. You'll find different animals in deserts, but at the same time, you'll find different animal species in the tundra region or in the polar region. So, the different animal species, they are part of zoo geography, but again, as a subject, it is encompassed or it is covered in zoology. Then we study ecology as well, human ecology. What is ecology? How we are interacting with the environment, how human beings are interacting with the environment for their own survival, and that is human ecology. And as well as it becomes another subject, that is environmental geography. So human ecology and environmental geography, they are part of a broader subject, that is environmental science or ecology. Then there is cultural geography, geographical thoughts, social geography, historical geography, political geography, population demography or geography. Then we have economic geography, and so on and so forth. So you will see that geography as a subject, it is not just one subject. When we talk about geography, it is closely related to each and every subject that is there in the social science as well as in the sciences as well. All right, so when we talk about geography, we have, like I said, we have two different branches. Physical geography that deals with studying the different process, the different phenomena, and as well as the patterns in our natural environment, whether it is atmosphere, whether it is biosphere or hydrosphere, anything that is happening in the natural environment, that is covered in the physical geography. And when we talk about the human geography, we study that is both, the human activity that is shaping or the, vice versa. The environment is shaping the human and the human have been shaping the environment. We both have a correlated interference with each other, and that we study when we study the human geography. So as a whole, we'll be studying the physical geography. In physical geography, like I said, we'll be studying the different physical aspects of the geography, whether it is the atmosphere, it is the hydrosphere, or it is the geomorphology, soil geography, and also ecology and environmental geography. As well as when we talk about the human geography, we'll be talking about the population and settlements, the economic geography, where we find minerals, where are the industries located, what are the factors for the industrial location, as well as the population and settlement, what led to the different type of settlements, whether it is the historical or the political causes, or how the rural and the urban areas have been developed, what all different type of economic activities they pursue there. All these things we'll be studying in our upcoming sessions. All right. Now, any doubts, anyone? Any doubts, anyone, up till now? Any doubts? All right, I guess there is no doubt. Can we move forward? So it is just an introduction about what is geography. All right, and how we will be covering the various aspects. Now we'll be talking about our first, the first chapter or the first unit, that is the universe as well as the solar system. Now, when we talk about the universe and the solar system, let me tell you what happens as, what you can expect when you are sitting for the UPSC examination. In UPSC examination, you will not find nowadays lots of questions which have been asked from the universe or the solar system. However, what you can expect, let me tell you. When we are talking about when we talk about universe and the solar system, let me just a second. I will write down what all you can expect here. So, when we're talking about universe and the solar system as a whole, what all types of things you can expect from here in the UPSC exam? All right. So, in UPSC, anything that is related to current events. The current affairs is very, very important. All right. So when we are talking about the universe and solar system, I'm just talking about universe and solar system. So when we talk about the universe and solar system, what you will find or how the questions will be asked from this unit, you will find the questions from current affairs. All right, you'll find the questions that will be asked from current affairs from this particular unit, or there could be questions which will be related to the various conceptual aspects. All right, now when I'm talking about various conceptual aspects, like for example, when we talk about there is when we'll be talking about the universe today. So when we'll be talking about the universe, there is, dark energy. So now what is dark energy? Such kind of questions you will find. The concepts have to be very well ingrained in your mind. The different types of concepts, the different type of, or you can say, not just concept, you can say that various conceptual aspects as well as, or various terms. The various terms which are there, they will be very, very important for your exam, for UPSC. All right. When we come to state PCS or state PSC, for any state PSC, you can find along with this. See, you have to cover the current affairs aspect. You have to cover the conceptual and the terms which are there, very, very important. And then if you are setting for the state PCS exam, so then there could be direct questions as well. There could be direct questions as well that could be asked from this particular chapter. But otherwise, I will generally suggest you that this particular chapter is not of so much importance when it comes to UPSC. All right. But again, when I talk about UPSC, what is the full form of UPSC? Union Public Service Commission. But it is actually not Union Public Service Commission. This is something, when we are talking about various kind of, exams, we say that this will be asked or this particular thing will be asked. But UPSC is, you cannot judge it or you cannot be very sure. So whenever a thing comes into your mind, even if you are reading anything except from geography as well, if you are reading a newspaper as well, and if you see and if you feel, oh, this is very small topic, I don't know, or I don't feel like UPSC will ask anything from that particular topic, be very sure that UPSC will ask from that topic. All right. If you are ignoring anything, if you are ignoring any part of your syllabus, if you are ignoring any topic from the current events, all right, have this thing in your mind that this could be asked in your UPSC. And that is how you understand UPSC as a whole. Now, when we talk about universe, what is universe? You all may know that universe is, it is nothing but it is what? It is the totality of everything. We can say the totality of everything or anything that exists is, whether it is known, it is supposed, or it is unknown. That is what we call as the universe. So throughout the space, that is universe. Whether it is any kind of known object. Now, when we are talking about known objects, so we have stars, we have different stars which are there, we have planets which are there, satellites as well, asteroids, meteors, comets, as well as the dust particles and gases. So that is the existing matter, or it is the known matter that is there. All right. So anything that is existing, matter as well as space, and which is not known to us, which is unknown and supposed, all that becomes as a whole the universe or the totality of everything. Now, when you talk about the structure of the universe, in most of the books you will find that the structure of the universe is negative curvature, or you can say that the negative curvature is basically an open structure or saddle like structure. Saddle is like this, an infinity shape. So this is saddle like this. However, when we are talking about the structure of the universe, by the theory of general relativity, under which the space also comes. All right, the space can curve itself and it can take any form out of the three forms. That is, the space can be flat, just like a sheet of a paper. It could be flat like a sheet of paper, flat. All right. It could be closed as well, like a sphere, or it could be open or negative curvature, or just like a saddle shape. So when we are talking about the structure of universe, the structure of universe can be of any three types. All right. So here you can see that these three types are here. We have a structure that is closed, the closed structure, or just like a spherical structure. It could be open as well. All right, open is negative curvature or just like a saddle. You must have seen saddles are used for horse riding. So when you are riding a horse, there is a saddle on the back of the horse on which you ride. So you'll find that this open structure is just like a saddle shape. All right, that is what we call as open, and it could also be flat structure. The flat structure is completely flat, just like a sheet of a paper. So the structure of the universe, it can have any of the three forms. All right, not just one form. It can be found in any three forms. Now, when we talk about different type of the terms, these terms we use interchangeably. Like I said, you have to understand terms, because that is how UPSC want you to understand the subjects. Now, there are three terms which we use interchangeably, that is cosmology, astronomy, as well as astrophysics. Basically, it is astronomy or cosmology. So we get confused what is what. Now, when we talk about cosmology, what is cosmology? Cosmology is nothing but it is the origin and the evolution of the earth and the universe. So when we are studying the various theories, how our universe came into existence, whether it is Big Bang theory, whether it is redshift theory, whether it is pulsating theory, or it is the steady state theory. So we have different types of theories which have been propounded. All right. So when we are talking about the different types of theories, how our earth or the universe came into existence, the origin, as well as the evolution of the universe, that is encompassed into cosmology. So the cosmic inflation, dark matter, dark energy, the cosmic microwave background radiation, CMBR, all these fundamental phenomena are basically included in cosmology. Now, When we talk about complete space, or when we focus on all of the space, that is the origin, evolution, the different, we have the different objects which are there in the space. So anything that is there, whether it is the planetary science, the stellar astronomy, the galactic or the galaxies which are there, extragalactic astronomy, cosmology. So everything is encompassed into a broader subject that we call as astronomy. So astronomy is a broader subject. Cosmology is just related to origin and universe, origin and evolution of the universe. And this is encompassed into a broader field that we called as astronomy. So astronomy is a broad field which completely focus on everything in the space, whether it is the evolution of the space, whether it is the, we'll say that whether it is the uh, origin of the space or the universe, anything that you can think of within the space, that is there in the astronomy. Now, there are basically various findings, you know, the findings which are related to the physical aspects in this space. Like there are various physical or the chemical structures that are there. So those are basically included in astrophysics. So in astrophysics, what we usually study, we study the physical and the chemical structures of various celestial bodies which are there. So that we study when we study the astrophysics. So that is the difference between cosmology, astronomy, and the astrophysics. All right. Now, when we talk about the origin of the universe or how our origin, the universe originated. So there have been various theories which have been propounded. Like I said, that, what happened was, as a human being, we were always curious. What led to the formation of the earth? What led to the formation of the universe? We were very curious about the origin and evolution of earth as well as the universe. However, in the earlier times, we did not had scientific advancements. So initially it was Ptolemy in 140, and in 140 AD or CE, what Ptolemy did was he said that Earth is the center of the universe. The complete universe revolves around our Earth. And that theory was propounded by Ptolemy. He said that the complete universe is revolving around the earth, and that is what was, later on it came to be known as geocentric theory. Geocentric means geo means earth and centric means at the center. So earth is at the center of the universe, and this theory was propounded by Ptolemy in 140 CE. All right, later on, it was Copernicus. Copernicus, he later on in 1543 said that no, it is not the earth but the sun around which the complete universe is revolving. Although both the theories were of no use, because later on we came to know that we are just a very smaller part in the universe, that the solar system or the sun and the planets which are there, they are part of the galaxy, and this was propounded, or it was actually seen by Herschel using the telescope. All right. So in 1805, he said that our solar system is part of the galaxy, and Earth is not the center of the universe, or sun is not the center of the universe. Later on, Edwin Hubble, with the use of telescope, he said that we have lots of galaxies which are there, and these galaxies together, they combine to form the universe. So that is how, initially there were various, you can say, various theories which were propounded leading to how the earth or the, universe has been formed. Now, when we are talking about when we are talking about the later advancements. So in the later advancements, we have a very much, the theory that is basically accepted, most accepted theory, and that is the Big Bang theory. The Big Bang theory has been propounded, and it is the most acceptable theory that we see today about the origin of the universe. And it says that everything started from a single point, and that single point or the point of singularity is from where our universe originated. As per the Big Bang, what happened was, all right, as per the Big Bang, what happened was that the complete matter that is there, the complete matter that is there in the universe, it was combined and it was basically in the form of a single atom. Before this, nothing existed. And this is what we call as the point of singularity. Now, you must all have heard about a term that is entropy. What is entropy? Entropy is nothing but it is the internal disturbance or the internal heat, you can say. Now, what happened was when the matter was so closely or compactly, it was embedded into a single atom, which we call as the primordial atom. All right, we had primordial atom. So what happened in the Big Bang? All matter and space, everything, it was basically composed in a single atom. This single atom was called as the primordial atom. Primordial means initial. So there was primordial atom that was there. And this primordial atom, what happened was because of the internal energy that was there. The internal energy was so big, it was so intense that it led to the explosion that we call as the Big Bang explosion. So there was a great explosion that happened, and this explosion happened nearly about 14 billion years ago. All right. And later on, due to this explosion, we had the universe that was formed. So in simple words, this is the Big Bang explosion or Big Bang theory. However, now when we talk about Big Bang, so the Big Bang theory or the Big Bang explosion has been proved with the help of cosmic microwave background radiation. See, it is the theory that whatever happens or the various radiations that are there, they stay. All right. And when this explosion happened, there was a microwave background radiation. They were the remnant of this expanding or the explosion that happened that resulted into the Big Bang theory. And with the discovery of these cosmic background radiations, now we can say that yes, and that is why Big Bang theory is the most acceptable theory because of the inventions or the discoveries, not invention, discovery of the cosmic microwave background radiation. So when we talk about the Big Bang, what happened was it was basically proposed by Georges Lemaitre and George Gamow. So George Lemaitre and just a second. All right. So what happened was George Lemaitre and George Gamow. You may be asked about both of these names, so you have to remember these names. The Big Bang theory is attributed to Georges Lemaitre as well as George Gamow. All right, both of them. Now, when we talk about the Big Bang theory, like I said, that during the Big Bang theory, what was proposed was that all the matter that is there in the universe, it was all concentrated in a very small, tiny ball. This small or tiny ball was the singular or primordial, or it was the primordial atom. Later on, the explosion, which occurred around 15 billion years ago, this was in the original theory. When we are talking about the original theory, so this was propounded in the original theory. Original theory said 15 billion years ago, but now we know that the explosion occurred somewhere 13.8 billion years ago. All right. Now the modern, after the discovery of the cosmic microwave background radiation, it is 13.8 or 13.7 billion years ago. All right, that you will find in most of the books. That is the exact age of our universe, when our universe started, or when our universe it was established or it originated. So this primeval atom or primordial atom, it disintegrated and it led to the rise of space as well as time. Before this period, there was no time, or you can say it was point of singularity. And that led to the formation of the universe because of the energy that was dissipated. The energy that was resulted, or it exploded. So there was energy that was created. That energy led to the expansion of the universe, and that expansion is continuing even till today. The universe is expanding. So this expansion, initially there were dark ages. All right, there were dark ages. Why there were dark ages? Because there was no matter that was there. So there was dark ages. After the Big Bang, there were dark ages, and during this period, various type of, you can say, the atoms, not atoms, the fundamental units of atoms were being formed. Whether it is electron, whether it is proton, whether it is positron, all these, the micro elements, they were getting formed. Later on, when they combined together, due to their combination, the first stars, they appeared. The first stars appeared because these matter, they combined together to form the hydrogen. Now, when hydrogen was formed, then there was explosion that started because energy was there. That energy resulted into the nuclear fusion. The hydrogen atoms, they combined and then they started generating energies. Today also, when you see the stars, what is the driving force behind the stars? It is hydrogen. It is the nuclear fusion. It is the helium. All right. And that is resulted into formation of the first stars nearly 300 million years ago. All right. And then after the, not 300 million years ago, 300 millions year after the Big Bang. Then the galaxies emerged, or the galaxies, they appeared, and later on there was the formation of the solar system. All right. And you can see that the funnel is expanding. We have the expanding universe. The expansion is even continuing today. How we know that the expansion is continuing today? I will explain this in the further slides, but let me tell you that the expansion of the matter, it is even continuing today, and we can know this by the redshift theory. Now, what is redshift theory? We will understand in the upcoming slides. So, we know about this because of the redshift phenomena, or you can say redshift theory. Like I said, that CMBR, or cosmic microwave background radiation, as well as Wilkinson microwave anisotropy probe that was sent, and the discovery of this CMBR, they led to the acceptability of this theory, that is the Big Bang theory. And that is why we say that the most acceptable theory about the origin of the universe, it is the Big Bang theory. All right. So you can see that this is how our universe has originated. All right. This is how our origin of the universe had done. So there was initially, when the Big Bang was there. So just after the Big Bang, there was the inflation. There were quarks that were formed. With the quarks, there were the first particles that were formed. The particles in the form of the neutrons, protons, and the dark matter, which we still do not know. Then later on, these particles, they combined to form the nuclei. The hydrogen and helium, they were formed. So the hydrogen and helium, they again because of the nuclear fusion, they started the energy. There was nuclear fusion, and that nuclear fusion started, and this nuclear fusion resulted into the first light, the first atom to being formed. And then later on, there were the gravity. Gravity resulted into formation of more stars, and those more stars, they resulted into formation of galaxies, which are nothing but they are the bunch of the stars. And then later on, our universe, it started expanding, or the expansion, it started. Later on, this expansion, the rate of the expansion, it increased. The acceleration increased. And it is believed that this increasing acceleration of the expansion of the universe is because of certain form of energy. This energy we do not know. Whatever we do not know, it is dark, right? So we do not know a matter, it is a dark matter. So the matter which is not known to us is a dark matter. The energy which is not known to us is dark energy. Dark energy and dark matter, they make the most of the universe, because still we are yet exploring the universe. Even today itself. Alright, even today we are exploring the universe, and that is why we have most of the universe that is still not known to us. So that is how we say that, that is how the universe came into existence, and this is the Big Bang theory. So you can see how the complete, time scale or the time existed. So at 10 raised to power minus 43 second, there was super fast inflation. It was expanding. There was a atom in the size of grapefruit, and later on it was expanding with a very fast pace. After the inflation, the universe, there were lots of electrons, quarks, and the other particles that were formed, and that resulted into formation of protons, neutrons, electrons, positrons, neutrinos, and different other particles, which resulted into formation of atoms. These atoms later on combined and formed the hydrogen and helium. Later on, lithium and beryllium were also formed, and then what happened was, due to hydrogen, light came into existence. So before this, there was completely dark age. Dark age means there was no light. Then the hydrogen helium, they started to bind together because of the gravity. They formed stars, they formed various stars, they formed the galaxies, and ultimately the galaxies, they were together. They when they were made, they formed the today's universe, which is still expanding. Now, based on, like I said, based on the recent explorations and the observations of the universe, the age of the earth is, the age of the universe is, it is 13.8 billion years. So initially it was propounded that the age is 15 billions, but now based on the Planck's observation, based on the Wilkinson's anisotropy probe that was launched, based on the cosmic microwave background radiation, this is the age of universe. The universe is composed of visible matter, the known matter, which is known to us. The known matter is just about 5%. It is just 4.9% of the complete universe that we know, and it is composed mainly of hydrogen, helium, and the other elements that you study in your chemistry periodic table. My question is, how many elements are known to human beings? Just write down in the comment box or in the chat box, so that I can understand that you are also actively listening to whatever I am saying. How many elements are known to human beings? Write down fast. Yes, very good. iPad. I don't know what your name is, but it shows iPad. Next time, please do remember to change your name. All right, you can change your name, I guess, when you are entering the session. So just try to change your name so that I can understand who is there in the class. What's your name, iPad? That's correct. We have 118 elements which are known to us. However, out of these 118 elements, only, okay, Shanu, that's nice. Only we have about 90 elements which occur in the nature freely. The next of the or the other elements which are known to us, they can be manufactured in the laboratory settings. All right. So the naturally occurring are just about 90 elements which are there. Now, when we talk about these elements, so we have 118 elements which are known to us. Now, there are various elements or various part of the universe which is still not known to us, or it is dark matter. So the dark matter, it is 26.8, or you can say it is about 27% of the universe. It cannot be seen visibly. We cannot see it with naked eyes or even with the telescope. We cannot see this matter, but we can have an inference. We cannot see it, but we can say that, okay, there is certain thing that exists over here. All right, like black holes. We cannot see black holes, but we can infer that there is a black hole which is existent over here because of the temporal distribution, because of the gravity, because of the orbital or rotational velocities which exist over there between the galaxies, or the missing masses. All these things led us to believe that there is certain matter that is existing there, but we do not know what matter, and that is dark matter, which we do not know, but it is there and we can infer. And there is dark energy. Like I said, the universe is expanding, but that expansion has to go on with a set pace or with a set acceleration. However, this acceleration is very fast, more than it should have been. So that means there is a matter or there is an energy that is responsible for this accelerated expansion of the universe, and that is dark energy. So dark energy is 68.3% of the complete universe. Then we have dark matter, which is 26.8%, and then we have the ordinary or the visible matter which can be seen on the galaxy or in the galaxies, in the universe, not galaxy, in the universe. All right. Now, what are the different evidences for the Big Bang theory? So like I said, there is Doppler shift or the red shift and blue shift. All right, Doppler effect. You must have heard about Doppler effect. You must have studied Doppler effect when you must have studied the in the physics. What is Doppler effect? Have you studied this in physics? Have you studied Doppler effect in physics? Okay, I'll give you an example. With the example, you will remember that you have studied this. In your 11th class or in your 10th class, you must have had an example that you are standing at a platform. A train is coming from a distance, all right, giving out a whistle or the horn. All right, a train is approaching you. You are standing at a particular place. A train is coming towards your direction. The frequency of the sound does not change. The frequency of the horn does not change. The wavelength of the horn doesn't change. But what happens is, wavelength changes, but frequency does not change. So what happens is that when the train is far away from you, the sound is very feeble. But as it is approaching you, you find it that it is the sound or the loudness is increasing. Do you see this? Do you hear this? Even if you are, on the road, you may have heard this, that when you are on the road and if somebody is approaching with the horn, so you'll find that the horn's intensity is going on increasing as it is approaching you. But however, the frequency remains same. All right. It is not that the frequency changes, and that is what we call as Doppler effect. The same thing is seen when a star is approaching or it is going away from an observer. Now, this is very important. Most of the students make mistake here. So please remember this, and please remember this by, with very, this is a concept. And like I said, the concepts have been asked in the examination. again and again. So when we are talking about the red shift or the blue shift, what happens is when the star is approaching you, so the light is made up of the white light is made up of how many? 7 different colors. What we call as Vibgyor, or it is the spectrum of the light, right? So when we're talking about these 7 colors or the spectrum of the light, so when a light is approaching you or when a star is approaching you, it is coming closer to the observer. Tell me, the wavelength will shift towards red or towards blue. Where it will shift? My question is, if a star, you are an observer, here is an observer, this is a star. This star is approaching towards observer, the wavelength will shift towards red or towards blue. Use your mind and give me the answer. Those who are in the class, please give me the answer. Where the wavelength will shift towards red or towards blue. Tell me, tell me. Okay, any guesses? Any guesses? Any guesses here? Red, yes. And that is the common mistake that we find. This is the common mistake that we find, Shanu. All right, and that is the mistake that most of the students they do in the exam as well. Actually, we think it in a common sense perspective. All right, if any star, because star is what? Star is hot, star has a heat, and when it is coming towards us, the light should shift to red, but it is not the same. All right, when a star is approaching, when a star approaches an observer, the wavelength it decreases. All right, and then it changes towards which wavelength? Towards blue. So there is a blue shift. All right. So always remember, when the object is moving, or as an object, when I'm talking about the object, I'm talking about the star here. So whenever the star is moving away from the observer, so when it is moving away from the observer, what you will see over here is that the Doppler will shift to lower frequency or higher wavelength. Always remember, you must have studied it, that the nu is equals to 1 upon lambda. All right, this you must have studied in physics. That is, frequency is just opposite to wavelength. They have inverse relation. So when an object is moving away, when object moves away or star moves, here we are talking about star. When a star moves away from the observer or from us, it will shift to lower frequency or higher wavelength. So the wavelength will get longer, and red has longer wavelength. That is why we use red in danger symbols. We use red in danger symbols. Why we use red in danger symbols? See, everything that we are studying right now, you must be seeing, you must be, thinking that this all we have studied in science. Sir is teaching us physics. Yes, that is what I was telling you beforehand, that geography is concept. Geography is all about science. Not complete geography, but physical geography. All right. So now, if the object is moving away from us, so it will shift to the lower frequency. Now, when it will shift to the lower frequency, what will happen? That the wavelength will get higher and longer. That will result into the shift towards the red spectrum, and this is called as red shift. Always remember, red shift will happen when the object will move away, not close to the observer. All right, it will move away, then there would be shift towards the red spectrum. Now, what happens when the object or the star moves closer to us? So when it is moving closer to us, what will happen is that the frequency will become higher. And higher the frequency, lower the wavelength. So that means the wavelength will get shorter and there would be blue shift. There would be blue shift when a star is approaching us. A star is coming towards us. All right. Now, my question is, I told you that universe is expanding. That means what shift you will be seeing in the universe? Red shift or blue shift? Which shift is visible in the universe at present? Please answer. What type of shift, red shift or blue shift you will be seeing? Very good, Shanu. All right, so we'll be seeing why I am saying what is the, I have told you that what is the, I have just told you that the first of the evidences of the Big Bang is Doppler shift or red or blue shift. So we are experiencing or we are seeing at present, we are seeing what? We are seeing the red shift, and this red shift shows that the universe is expanding. Universe will be expanding only when there would have been Big Bang explosion, right? You must have seen or you must have during the times of Diwali season, all right, Deepavali or Diwali, you must have burnt crackers using something on the top of it. You know, we use cartons or something, we are burning crackers, we put carton on top of it. So when there is a bang or explosion, what happens is that the carton goes boom, it explodes. So that is what happens when we had the Big Bang theory or Big Bang explosion. That resulted into the formation of our universe. And when we are talking about this, this is the first evidence that we can see in the universe, that is today the universe is expanding or we are having the red shift in our universe that that goes along with the Big Bang theory. The second is the cosmological microwave background radiation as well as the gravitational waves which have been discovered, which lead us to believe that Big Bang theory occurred. All right. So this is one of the theory, the most acceptable theory about the origin of the universe. Another theory about the origin of the universe is steady state theory. Now, what is steady state theory? When we are talking about the Big Bang explosion, so Big Bang theory says that our our universe is expanding. Our universe is expanding. That means there is a visible cosmic horizon. What is cosmic horizon? Up to a place where we can see that this is the universe. That is about 13.8 million light years ago apart. We can see that this is the boundary of the universe. Now, when the universe is expanding, some of the particles, they will leave the universe and they will go outside that visible boundary or the cosmic horizon. Now, steady state says, Big Bang says that the matter is getting diluted. The universe is expanding. Some of the matter is going outside the universe, the visible sphere that is there. But steady state says, steady state is opposed to it, and it says that we have matter that is being constantly created as our universe is expanding. So steady state, which has been proposed by, please remember these names, Herman Bondi, Thomas Gold and Fred Hoyle. So they said that the galaxies which are there in our universe, they remain constant. How they remain constant? They remain constant because new galaxies are being formed continuously and they are filling the empty spaces, and the older galaxies, they are going or they are crossing the boundary of the observable universe or the cosmic horizon, and thus we have the number of galaxies which are constant. So that is what steady state theory says. However, later on steady state theory was not accepted after the acceptance of the Big Bang theory. So now the most, like I said, the most acceptable theory about the origin of the universe, it is Big Bang theory. The second theory, that is pulsating theory. The pulsating theory was proposed by Einstein himself. We had Einstein as well as Richard C. Tolman and Friedman who proposed this theory. Now, what happened? What happened was that we had a Big Bang explosion. Big Bang explosion occurred. There was point of singularity, and from a singularity, Big Bang explosion occurred. We had the Big Bang, and this Big Bang explosion, it gave the required energy for the expansion of the universe. Now our universe is expanding, but you all must have heard about the law of conservation of energy. The law of conservation of energy says that the energy cannot be created nor be destroyed. However, it can be changed from one form to another. Right? This is law of conservation of energy, that the energy cannot be created nor be destroyed. Now, what happened? Big Bang explosion occurred. It gave the kinetic energy, the explosion or the heat energy that was dissipated. It gave the kinetic energy, it gave the momentum, and the universe started expanding. But that heat energy is getting transferred into or transformed into kinetic energy. At certain point of time, that energy will exhaust. Now, when that energy will exhaust, what will happen is when this energy will be exhausted, so there will be no energy that will be deriving the universe in expansion. So now what will happen is there would be a gravitational force that will be acting. Now gravity will act upon all the objects that are there. When the gravity will act on all the objects which are there, they will start into contracting back again. They will contract into another primordial atom. There will be another atom that will be formed, and then again there would be an expansion or the Big Bang explosion. So there was a primordial atom, explosion occurred, it started expanding, the energy gets exhausted. When it gets exhausted, again gravity acts, and because of the gravitational force, all the matter, it gets pulled together. Again it forms a primordial atom, again explosion, again gravitation, again explosion. So this act as a pulsating, or it act in a cyclical manner. So this was the pulsating theory. All right, that universe at present is expanding because we know why it is expanding, because of we know by the redshift phenomena. There is redshift that is happening. Because of the redshift phenomena, we know that the earth or the universe is expanding. After some time, this expansion will stop, the contraction will begin. Why? Because of the gravitational force. So after the expansion will stop, gravity, it will lead to the contraction of the universe. It will occur until there will be a newer explosion, newer Big Bang, and the universe will again expand, and this will keep on going. That is what is a pulsating theory is. All right. Now, so these were the different theories which were given and which actually resulted, or you can say that they were the prominent theories about the origin of the universe, how the universe was originated. Later on, however, like I said, it was the Big Bang theory which was accepted, mostly accepted. So when we talk about the age of the universe, the astronomers, they have estimated that Big Bang occurred somewhere between 14 to 12 billion years ago. And right now we know that the age of the universe is about 13.8 or 13.7 billion years ago on the basis of CMBR, or cosmic microwave background radiation. However, our solar system is quite new. All right. The universe was formed actually at 13.7 billion years ago, but our solar system, it formed just 4.5 billion years ago. All right. So when we are calculating the age of the universe, we use two different methods. We use the observations. There are different globular clusters, all right, which are there, and there are various stars which are there. We have different old stars which are there. So by measuring the rate of expansion or by observations on the basis of the clusters which are there, we can estimate the age of the universe. And there is also a possibility. This is just a hypothetical situation. What is hypothetical situation? Which cannot be proved, or which is just a theory, but it has no proof of evidence. So there is another hypothetical situation of big crunch. Now, what is big crunch? We know that the universe at present is expanding and our universe has a certain density. Now, there is density of the universe if it is greater than critical density. What is critical density? Which is square of Hubble constant. Now, what is Hubble constant? What is Hubble constant? Hubble constant is nothing but it is the rate of expansion of the universe. So when we are talking about critical density, suppose rho C, that is critical density. So it will be how much? It will be Hubble constant. This is Hubble constant. So its square, it is proportional to square of the Hubble constant. And Hubble constant is 160 kilometer per second per million light years. So if the density of the universe, if we are talking about density, rho universe, it becomes greater than critical density. So what happens next? So what happens next? Next happens the big crunch. That is, the gravity will be more and the universe, it will collapse onto itself. The universe will be no more. And that is what we call as big crunch. When this big crunch will happen? When the universe's density will be more than critical density. What is critical density? Is proportional to Hubble constant's square. All right. Clear everyone? Now anyone has any doubts in universe? Do you have any doubt? Anyone? Or anything that you want to ask up till now? Anyone? Yes, you can unmute yourself and you can speak if you have any doubts. All right, so we'll be moving ahead and we'll be covering the other aspects as well. Like we'll be talking about galaxies, we'll be talking about star, the life cycle of the star. So, before I move forward, I will just like you all to have 5 minutes of break in between and just recap in your mind what we have studied so far. All right. In this way, our brain functions because if we are going on for like 2 hours, 2.5 hours continuously, our brain gets foggy. So I will ask every one of you who is present right now, take 5 minutes break and recap everything that we have studied. Get ready for the next part of the session of today's. That is, we'll be studying about the galaxies as well as stars and the solar system as well. All right. So I'll see you in 5 minutes. All right. It's 12:20 and we'll continue from 12:25. All right. Thank you. All right. So I guess this is clear to everyone. Any doubts? If you have any doubts, you can unmute yourself and you can ask your doubts. None? Okay. So, like I said, universe is totality of everything. Whatever exists, whether it is matter, whether it is space, whether it is time, everything is considered or it is there in the universe. Now, when we are talking about the galaxies, what are the galaxies? When you talk about the galaxies, it is nothing but it is the collection of the stars. We have different stars which are there. They form together, or when they are together as a group, that is called as galaxy. All right. So the galaxies, they are the collection of stars. Along with stars, there would be dust, gases, as well as the dark matter that will be bound by gravity. There are certain vast galaxies. There would be a term, it may be asked in your examination, that what is an island universe. So actually island universe is nothing, but it is basically the vast galaxies which are there. They are termed as the, or they are known as the island universe. They are called as the island universe. Now, we have different galaxies which are there in the universe. They are, or they come with the different size, shape as well as structure. The galaxies, they could be elliptical, spiral or irregular. Now, the shape of the galaxy, it also tells us the age of the galaxy. The irregular galaxy is such type of galaxy which do not have any shape. They are the new galaxies. The new galaxies which will be formed, they will be basically a irregular galaxy. Now, when an irregular galaxy, it becomes mature. It becomes mature, or with the time, the time passes, it becomes a spiral galaxy. All right, like M101 or like our own galaxy, that is Milky Way. Milky Way is what? It is a spiral galaxy. So, when we have mature galaxies, or you can say they are intermediate between irregular and elliptical. These galaxies are between both of them, irregular and elliptical. And then comes elliptical galaxies. The elliptical galaxies are the oldest galaxies, or they are the old galaxies. So the old galaxies, they would be found in the elliptical manner. So you can say that most of the galaxies that are there in the universe, they are mature galaxies. We have more of spiral galaxies. We have 18% which are elliptical galaxies, and we have just 0.2% galaxies which are the irregular, or they are the new galaxies which could be found. All right. Now, when we talk about the galaxies are basically, they are formed of the various stars. Even our galaxy, that is Milky Way galaxy, it is composed of 200 billion stars. We have our Earth that is there in one of the arm. Our galaxy is, again, our galaxy is what? Our galaxy is, like I said, it is also a spiral galaxy. You can see over here, the shape of the galaxy is spiral galaxy. That is our galaxy. And when we are talking about the spiral galaxy or our Milky Way galaxy, you can see that our sun is in one of its arm. This arm is called as Airavat Path. This is known as Airavat Path. All right. This is the name of the arm in which our solar system resides, or our solar system is there. So it is Airavat Path. This is our sun that is there, or solar neighborhood. And then we have the complete galaxy, which is composed of 200 billion stars. Now, when we talk about the star, there is a complete life cycle of a star that is there. The life cycle of the star, it tells us that in what stage the star is at present, or what is the stage of the star right now. Like we we are born, we after our birth, we become mature, we become adult, and then we get into the aging phase, we get old, and later on we die. That is the life cycle of a human being, right from birth to the death. That is the same with the stars as well. The stars are also born. After the birth of the star, they move towards their own, life cycle, or they move towards their own, you can say the phases, and later on, afterwards, they die as well. So the star is formed from the gases and dust particles. And when we have a cloud of gases or dust particle, that cloud is called as nebula. What is nebula? Nebula is nothing but it is the cloud of gases and dust particles. So gases and dust particles are called as the cloud is called as the nebula or star forming nebula. Now what will happen is that in this nebula there would be gravitational attraction, because this is what, these are the elements, this is a cloud. So in this cloud there would be a gravitational attraction or the gravitational binding, and this gravitational pull, it will result into start of the nuclear fusion. Now, depending upon the size, if the size of the nebula is less, like for example, this is Eagle Nebula. Eagle Nebula is example of a nebula that is star forming nebula. Now, what will happen is if the size is considerably small, the nebula is small, so it will change into red dwarf. That means the nuclear fusion, it will not be of that much big scale that it can convert into proper star. It will be a red dwarf. Dwarf means small in size, and red because the nuclear fusion is not at the full scale power. So it will look like red, reddish in color, small in size, and that would be called as red dwarf star. Now, as the light will go on diminishing, or you can say as the nuclear fusion will come to an end. So, as it comes to an end, what will happen is that this red dwarf, it will change into blue dwarf. There would be a blue dwarf that would be formed later on as the nuclear fusion completely stops. So, there would be complete stoppage and it will change into the white dwarf, and ultimately this white dwarf will die, and after its death it will be called as, or it will be known as, black dwarf. So this is when the solar forming or the star forming nebula is considerably small. It is not of a proper size, or the gravity is not that much that it can result into full-fledged nuclear fusion. However, if this is of considerable size, it will lead to the formation of protostar. What is a protostar? It is the first star that is born, or you can say newborn star. Newborn star is called as the protostar, like V1647 Orionis. Now, depending upon the mass again, there could be two different phases or the life cycle that they could undertake. So, we have a newborn star, protostar. Depending upon the size of that star, what will happen is here that it can change into mid-sized star if the mass is low of this protostar. If the mass is low, it will change to mid-sized star like our sun, and then slowly as the nuclear fusion will occur. So what happens in nuclear fusion? What happens in nuclear fusion? In nuclear fusion, simply the lighter elements, they get changed into heavier atoms, right? The lighter atoms, they change into heavier atoms. So because of the nuclear fusion, the star will increase in size. The star will increase in size. Lighter elements, they are changing into heavier elements. The size will increase. But at the same time, what will happen? The hydrogen from the outer layers, it will get exhausted. But the hydrogen will still be there at the core. So it will look like red from the outside. And because it swells in the size, so it will be a red giant. So over here, hydrogen gets exhausted from outer layers. All right, and the size increases. Now what will happen? I gave you an example of, burning crackers during Diwali season. What happens when you plant a cracker and then you plant a carton on top of it? Now the pressure inside is so much when explosion happens or explosion occurs that it explodes the outer carton as well because of the pressure. The same thing happens when we have red giant. In red giant, the inner core still is active. In red giant, inner core, in the inner core, what is happening? In the inner core, nuclear fusion is still happening. But the outer core, it is now exhausted of the, or the nuclear fusion has stopped from the outer shells or from the outer layers. Now, there is still explosion that is happening in the core, but the outer layers are surrounding, there is no nuclear fusion. So what will happen? Because of the pressure that exerts from the interior or from the core, there would be a blast of the outer layers. So this blast of outer layers, what will happen in blast of outer layers? The outer layers which are composed of outer layers, now they are composed of various elements, various minerals that would be there, or you can say that these outer layers, they are composed of the various segments or elements. Now when they will get blasted, they will change into dust particles, and those dust particles, they are basically what? It will change into a cloud of dust particles or gases, and that will be again a planetary nebula. And this explosion is, or this blast of the outer layers, what is this called? This blast is called as nova explosion. There would be a nova explosion, and after nova explosion only the core will remain. So the core remains, and this core again, we have the core, this core again, when the nuclear fusion will stop, it will change into white dwarf. Afterwards, after the complete, the death of the star, it will change into the black dwarf. So that is how a medium size or low mass star behaves. But if the mass of the star will be more, if the mass of the star will be more, what will happen is it will change into a massive star like Spica. Then later on, the giant, the red giant will be super giant because it is a high mass star. So there is a mass, heavy mass star is there. So the size of the red giant will be very, very much greater than red giant. It will be called as red supergiant. In the red supergiant, again, what will happen is there would be nova explosion. But here again, this explosion will be tremendously large as compared to nova explosion. So this will be called as supernova explosion. It will be called a supernova explosion. And after supernova explosion, again, we will have the core that will remain. So there will be core that will remain here, just the core. Now, depending upon this core's size, what is the core's size is, depending upon this, the star can change into All right, guys. So there was some internet connectivity issue. So let me share the screen again. All right. So, like I was telling you that when we are talking about the life cycle of the star, this is how life cycle of the star, it is basically, you can see that how it progresses. So I told you that for a medium sized star, it grows in size, and when it grows in size, it becomes red giant. The red giant, later on, because there is still explosion that is happening, the nuclear fusion that is happening at the core, and the outer layers, they are exhausted of the nuclear fusion. So there is a explosion which we call as nova explosion. Later on, only the core remains, which changes into white dwarf and then again to the black dwarf. The same process happens for the massive star as well, but only at a larger scale. So in massive star, the red giant will be red supergiant because it will be massive in size. Later on, when the nova explosion will happen, it will be a supernova explosion. After supernova explosion, the core will remain, and depending upon the core size, it may become a neutron star or it may become a black hole. Now, we all know, all right, and we will study in the further session as well. When we talk about the core, when we are talking about the core, what happens is that the core is basically made up of more of, you can say that, dense material. All right. Core is made up of more dense material. And the same thing happens with the star as well. The density will be more at the core level. And the density, if it is more than 1.44 times mass of our sun, all right, if it is more than 1.44 times, all right, just a sec. Okay, when it is more than 1.44 times our mass of sun, all right, or it is less than 1.44 times mass of our sun. All right, what is Sm? I'll write here. Sm is equals to mass of our sun. That is Sm. So depending upon the mass of the remaining core, it can change into neutron star or it can change into the black hole. Now what happens is, you must have seen ballerinas. Ballerinas which, there are various dance, or you must have seen the, ice board skating or ice board dancing that is there in, movies or in videos you must have seen. What happens when a dancer is rotating? When a dancer is rotating, when they open their arms, their rotation, it becomes slower. But when what they do is they just move their arms closer to their body, the rotation will increase. Now the same thing happens over here as well, because the core size, it is dense, the core is dense, and the outer layers they have been expelled because of the explosion. So now the core will be spinning at very fast rotation. First thing. Second thing is the density will be higher. So because of the density, the gravity will again increase. Why the gravity will increase? Because we know what is the formula of gravity. G is equals to G m1 m2 upon r square. That is the formula of gravity. We must have studied this in physics, right? You must have studied this in physics. So now, when we are talking about, this is between two objects, but when we see the gravity for single object, like for example, I'm talking about Earth. So when we are talking about Earth, so it becomes GE, or here I will use G any planet or any object. it becomes equal to G m mass of that particular planet or object upon r of or radius of that particular planet or object square. So this is how we calculate the acceleration due to gravity of the earth, right? This is how we calculate acceleration due to gravity of the earth. Now, because the radius has reduced, now the outer layers have been expelled. So now what will happen is the gravity will increase tremendously. The gravity will increase tremendously, and when the gravity will increase tremendously, what will happen? The electrons, they will start degenerating into neutrons. What will happen is the electrons will degenerate into neutrons due to the gravity, and they form neutron star. Now this neutron star, when it will be spinning with a greater rotational speed, it gives out the pulses, the radio waves. It gives out radio waves in pulses, and that is when it is called as pulsar, or it is also known as quasar. Alright, so neutron star, it could be pulsar or quasar. And the neutron star is made when the core size after the supernova explosion is less than 1.44 times the mass of our sun. But if it is more than 1.44 times mass of our sun, what will happen? The gravity will be so intense. The gravity will be so intense that because of that gravity, it will even not allow the light to escape, and that is when black holes are generated. Now, everyone, you got the idea how the star is formed and how it gets dyed, why the neutron star are formed, why the black holes are formed, or what is the life cycle of the star. Any doubts in the life cycle of the star, you may ask in the chat, or you may also unmute yourself and ask your doubt. Any doubts, anyone? Any doubts? None? Okay. Now, so this is the life cycle of the complete star. How a star is formed and ultimately how any star dies. Alright. Now, over here you can see how the matter gets degenerated. Alright. The electrons, they run out of the room to move around nuclei, and then they are forced into lowest energy quantum state, which forms the what? White dwarf. So white dwarf and later on the black dwarf are being formed. They are formed when we are talking about the red dwarf, the life cycle of the red dwarf, or the life cycle of the mid-sized sun. So in that condition, they are formed. But when we are talking about the neutron star, in the neutron star, the protons, they are forced to absorb the electrons which are rotating around because of the gravity. And when the protons absorb the electrons, they get converted into neutrons, and neutrons, when they are squeezed together, they form the neutron star, which could also be a quasar or it could be a pulsar. And the black hole is formed when the neutrons, they collapse completely. And when they collapse completely out of the gravity, even the light cannot escape, and that results into formation of the black hole. So all these three states of the life cycle of the star, whether it is white dwarf, neutron star, or black hole, they are basically they are formed because of the degeneration of the matter. All right. Okay. Now, I have told you that there is a limit. The limit, that is 1.44 times the mass of the star, that decides whether a star will form after the supernova explosion, whether it will form as a neutron star or it will form a black hole. So this limit was basically, it was decided or it was calculated by Subramaniam Chandrasekhar. And on his name, this limit is called as Chandrasekhar limit. That is 1.44 times mass of our sun. So it is called as Chandrasekhar limit. It was calculated by Subramaniam Chandrasekhar, and he calculated this limit that beyond this limit, if the limit or the size of the core after the supernova explosion is more than 1.44 times that of the mass of the sun, then it will collapse and it will change into the black hole. But if it is less than the Chandrasekhar limit, that is limit of 1.44 times mass of our sun, then it will collapse, but it will get stable at the neutron degeneracy and it will convert into a neutron star. All right. Now, when we talk about the stars, the group or combination of different stars, when we see in the sky, they generally form a group, or they could be distinguished on the basis of the different shapes they get arranged in the sky, night sky. And on that basis, we call them, the group of stars, we call them as constellations. Now, my question is, how many constellations are recognized in the sky? How many constellations are there? Answer in the chat box. Let me know if you know the answer. And if you do not know, write do not know. Let me know if you know how many constellations are there. Let's see who will answer this question. How many constellations are there in the sky? Or they are recognized? Yes, very good. So there are total 88 constellations which are there. Very good. What's your name? I cannot get your name here. What's your name? Your Ritisha. Okay. Very good, Ritisha. So we have total 88 constellations which are known. And on that basis, like we have the, Saptarishi, or we also call it Big Dipper. So with the help of such constellations, earlier times, what used to happen was, so people used to follow these constellations to know the directions. All right. They had very good knowledge about the constellations, how they are placed in the night sky. And with the use of these constellations, the Polar Bear, Big Dipper, or the Saptarishi, Cassiopeia, they used to, see the pole star, the directions, and they ultimately used to guide themselves through the night sky. Now, the stars, when they are, when it has a family, solar system. When we talk about solar system, what is solar system? It is nothing but the sun's family. So in sun's family, we have the sun. Sun is you can say he is the head of the family. So we have sun, along with sun, we have stars as well. Sorry, not stars. We have planets with the sun. We have planets. The planets have their satellites. I'm talking about natural satellites. So certain planets, just, we do not have satellite for the initial two planets, that is Mercury and Venus. So apart from Mercury and Venus, all the planets have their satellites. So we have sun, planets, satellites. Along with this, we have asteroids, which are there. Asteroid belt is there. We have comets. We have meteors in the solar system. We have dust. We have gas particles. We have Kuiper belt objects. All these things together, they form the sun family that we call as solar system. Now, when we talk about the solar system, the formation of the solar system, or we can also say the origin of the solar system, various different hypotheses. Like I said, hypotheses are various theories which cannot be proved or which do not have a solid proof. So we have lots of hypotheses which were propounded by various geographers that were propounded. Now, when I talk about these hypotheses, what kind of questions you may get from it? So you may get from it the type of question, you may have a match the following question. All right, so we have different type of hypotheses which were propounded by various geographers. The first and the foremost is the gaseous or the nebular hypothesis. The gaseous or nebular hypothesis, it was given by Kenton Laplace. Later on, it was further modified into nebular cloud hypothesis, and this was given by Dr. von Weizsäcker. Now, it is the most prominent theory, or the most prominent, you can say, accepted theory, that is nebular hypothesis theory. All right. Later on, other hypotheses were also given, like planetesimal hypothesis by Chamberlain and Moulton, tidal hypothesis by Sir James Jeffreys and Harold Jeffreys, binary star hypothesis H. N. Russell, supernova hypothesis Fred Hoyle, interstellar dust hypothesis by Otto Smith, electromagnetic hypothesis by H. Elfven, and protoplanet hypothesis by G. Cupier. So, like I said, you do not have to delve more into these different type of hypotheses because you are not learning geography as an optional subject. If we would have been studying geography as an optional subject, so then we would be delving into each of these particular hypotheses. We'll be understanding what all these hypotheses are all about. But for your prelims, for your mains, you just have to remember the name and the propounders. All right? Because the question that would be asked would be in prelims about the and that would be the match the following type of question. Now, out of these, the prominent one is the gaseous or the nebular hypothesis. All right. Now, what is the gaseous or nebular hypothesis? Let's discuss this in detail because this is one of the most prominent one. Now, when we talk about the gaseous or the solar hypothesis, gaseous or the nebular hypothesis, what happens here? Now, I have told you that what is a nebula. Nebula is nothing. Just a sec. Okay. Over here. So, what is a nebula? When I'm talking about nebula, what is a nebula? Nebula is nothing but it is the cloud. It is the cloud of gas and dust particle. So there was a big cloud of gas and dust particles. All right, there was a big cloud of gas and dust particle that was there. This was a nebula. All right, this was a nebula. What is a nebula? I told you it is a cloud. Cloud of gas as well as dust particles. Now, what happened into this particular nebula? Nebula, it resulted into gravitation. There was a gravity. Just a second. Let me use a different pen for marking the progress. So now what happened was, when this nebula was there, it was cloud of gas and dust particles. So what resulted afterwards? It resulted into formation of sun. We had our sun that was formed because of the gravity. There was gravity that came into role play, and due to this gravity, most of the nebula or most of the cloud, it got concentrated in between. All right, due to gravity, most of the cloud, it got concentrated in between, and the rest of the gases and dust particles, they started revolving around this central mass. So what happened was, in between there was a, due to gravity, this was later on, because of gravity, it changed into sun. So this was sun that was created, and then there was a disc-like structure that was created around this particular mass of the sun. This is cloud of gas and dust particles. It concentrated in between, most of it, and that actually explains why most of the mass, when we talk about the solar system, maximum mass, 99% of the mass of the solar system is there in the sun. Why? Because of the gravity. Most of the nebula, it concentrated at the center, and the rest of the mass started rotating around this solar nebula, and this came to be known as the protoplanetary disk. It came to be known as protoplanetary disk. Now, what happened later on was that the solar nebula or the nebula that concentrated in between, it changed into sun. It got changed into because of the gravity. What it resulted into? It resulted into formation of the sun and the protoplanetary disk. It then later on, this became sun at the at the center, and the protoplanetary disk, there was again gravity, the gravitational force that led to the formation of different layers, and in these layers there were different planets which were formed, and this resulted into formation of the solar system. So that is what is a nebular hypothesis is. Nebular hypothesis says that our solar system was originated, or our solar system came into existence from the same nebula which resulted into formation of our own sun. So that is the nebular hypothesis. Like I said, the solar system, it consists of the sun, and 99.99% of the mass of the solar system, it is concentrated in the sun. And this again is proved by the hypothesis, nebular hypothesis. Our sun is at the center, and there are 8 different planets which have been arranged into 4 inner and 4 outer planets. We have Mercury, Venus, Earth and Mars, as well as Jupiter, Saturn, Uranus and Neptune. We have their satellite except from Mercury and Venus, which do not have any satellites. We have dwarf planet, asteroid, meteors and comets, as well as dust and gas particles which form our solar system. Clear? Over here you can see we have Sun, then we have Mercury, Venus, Earth and Mars. Then we have asteroid belt between Mars and Jupiter. Then we have outer planets, that is Jupiter, Saturn, Uranus and Neptune. Then we have Pluto. Pluto, which was earlier, it was a planet. However, after 2006, it was degraded as a dwarf planet. Also, we have Kuiper belt objects, and you can see over here we have the different we have the dwarf planets as well. Ceres is a dwarf planet. It is also the largest asteroid. Alright, Ceres is both. It is asteroid as well because it is there in the asteroid belt. It is also a dwarf planet and it is the largest asteroid. Alright, we also have Pluto. It is also a dwarf planet. We have Makemake, we have Eris. Alright, and these are the dwarf planets. We also have comets which are there. They are basically the the comets which originate from the Kuiper belt objects. So they are also revolving around the sun. So all these, they combined, they form the sun's family or the solar system. Now when we talk about the sun, we'll just talk about some of the factual information, because certain times when you are sitting for the PCS examination, these things have been asked. All right. So the sun is the yellow dwarf star, and the age is about 5 billion years ago. It was formed. It is nearest star from the Earth. Please remember, it is very important to read questions carefully. Whenever you are sitting for the UPSC examination, civil services examination, what happens is, UPSC has a tendency to play with the words. So you have to read carefully the questions before attempting the answers. So it is the nearest star from the Earth, and the distance is about 150 million kilometers, the approximate distance or the mean distance, and this is also called as an astronomical unit. It is a astronomical unit, and it is also a unit of measurement of distances in the sky or in the space. So it is the nearest star from the Earth. The mean distance is 150 million kilometers, and it is source of almost all the energy of the Earth as well as the universe of the solar system. We have 2 major gases which are here, which plays a major role play in the nuclear fusion. We have hydrogen and helium. Its surface temperature is 5500 Celsius or 5800 Kelvin, and the core temperature is 1 crore 56,000 Celsius or 1.57 million Kelvin. It takes 20 to 24 million years to complete a revolution, which is called as cosmic year. So, what is a cosmic year? Like I said, our galaxy, the Milky Way galaxy, is a spiral galaxy. When we are talking about the spiral galaxy, there are various arms which extends from the center. We have different arms, and our sun or solar system is somewhere here. So, this complete galaxy is rotating. It is rotating on its, all right, it is rotating like this. So when it is rotating, the sun actually starts a complete circle because of this rotation, and it completes a revolution around the galaxy, and this revolution is called as or termed as cosmic year. It is 224 million years, and it also rotates around its center or around its axis. But sun is a gaseous giant. Sun is a gaseous giant. It is not solid like Earth. When it is not solid like Earth, so the rotation will not be equal at all the points, because it is just like gases which are rotating. So the rotation will be different, and it is 25 days at the equator and 36 days at the poles. Why? Because it is a gaseous giant. It is gaseous. It is made up of gases, and that is why the rotation is not uniform at the equator or at the poles. Now, you must have seen that the sunlight is a white light, but in actual, it is not exactly white. There are certain black lines or dark lines which are superimposed on these white light. These lines are called as Fraunhofer lines. These Fraunhofer lines basically, they tell, or they are the, you can say that they are that there are certain elements which are present on the surface of the earth. So we know about different elements which are present, because these Fraunhofer lines, they signify various elements which are present on surface of the sun. They signify elements of the sun, and we come to know about the different elements which are present on the sun because of these Fraunhofer lines. Now, there are different layers of the sun as well. Now, these layers, when we are talking about these layers, we have two different type of layer. We have inner layer as well. We have the outer layer as well. So, in the inner layer, we have the first layer, that is the core. Core is the innermost layer, all right. Then comes the radiative zone. This is the second layer of the sun, radiative zone. And then we have the third layer, that is the convective zone. Then comes the surface of the sun. So when we talk about the internal layers, these are the internal layers of the sun. Core, then we have radiative zone, and then we have the convective zone. Now, when we talk about the surface layers, so on the surface layer, we have again three different type of layers. We have photosphere, which is the innermost layer. We have photosphere. Then comes the second layer, which is chromosphere, and then we have the corona. Remember that corona is only visible during the when? During the solar eclipse. It is only visible during solar eclipse. Although it is there, but it is not visible. It can be visible during solar eclipse, and it looks like a ring outside, you'll find it like a ring. So it is only visible during the solar eclipse. Then we have also different phenomena that is associated with the sun. Like we have flares. The flares are basically, solar flares, which are the charged particles from the solar winds. All right, or they are the charged particles, and when they leave the solar surface, these charged particles, when they leave the solar sphere or the surface, they become the solar wind, these charged particles, which when they come towards Earth as well, but Earth has a magnetosphere. It has a magnetic field. So when they come near the Earth's surface or meet with the Earth's magnetic field, what happens is, because they are also charged particles, Earth has a magnetic field, it leads to formation of lights, which are called as the polar lights. All right, or they are also known as auroras. I'll show you how aurora look like. Then we have prominences also. Prominences are again, they are bouts of solar flare. They would be at one end, they would be joined at the sun surface, and the other end will be moving outside the surface as well. Then there would be sunspot as well. What are sunspots? Sunspots are the regions of low temperature on surface. Have you studied Bernoulli's? Bernoulli's theorem? Have you studied Bernoulli's theorem? What is Bernoulli's theorem? Okay, even if you have not studied Bernoulli's theorem, I guess you must have washed your bikes, your scooters, or your car using pipe. Using pipe, you have washed your cars, scooters, bike. So what happens is, when we use or when we want to increase the pressure, what we do is we close the nip of that particular pipe. All right, the tip of that pipe. So what happens is, as we close it, the pressure increases. Now the same thing happens when we have sunspot as well. As we have sunspot, the regions which are closer to that sunspot, because at the sunspot the temperature is lower, the temperature gets lower. So what will happen? The regions which are near to that sunspot, the temperature will rise, and that is what is called as the plages. So we have plages. We'll have plages, we have sunspot, then after the sunspot we will have the plages. What will be the plages? They will be the regions of high temperature. And where they will be found? They will be found just around the sunspots. Where you will have the sunspot, you will find the plages that will be there. All right. And solar wind, like I said, solar wind are also the charged particles, the charged electrons and protons. The charged particles, when they leave the surface of the earth, so of the sun, they become the solar wind, and they can travel up to a longer distance in the solar system. Now, after the sun comes the planets. When you talk about the planets, what are the planets? Basically, the planets, the term has been derived from Greek word planetai. Planetai means wanderer. And these planets, they revolve around the sun because they are wanderer. They are wandering around the sun in elliptical paths, which is called as the orbit. The movement around their own axis is called as rotation, and the movement around the sun is called as the revolution. So these two movements you will find in all the planets. The planets, they do not have their own light or their own heat, and like I said, they are classified into inner and outer. The inner planets are the 4 planets. They are also called as terrestrial because they have solid surface. So they have solid surface, solid crust, and that is why they are called as terrestrial. However, the outer planets, or the 4 outer ones, they are called as Jovian, or you can say Jupiter-like. Jovian means Jupiter-like, or you can say they are also gaseous giant. They are formed by gases. They are not, their crust is not solid. The crust is basically gaseous. So the inner planets or the terrestrial planets, we have 4, that is Mercury, Venus, Earth and Mars. And outer or the Jovian planets, we have Jupiter, Saturn, Uranus and Neptune. So these are the planets, as you can see, as we are moving away from the sun. Now, like I said, till 24th August 2006, Pluto was also a planet. However, there was a definition that was given by IAU, or International Astronomical Union, and according to it, the definition says that a planet will be classified as a planet only if it is a celestial object, and it fulfills three conditions. There were three conditions for a planet. The first condition is that it is in orbit around the sun. It is in orbit around the sun in an elliptical path. All right. Second is that it has sufficient mass. It has sufficient mass so that, out of gravity, because of gravity, it assumes a nearly round shape, or it assumes a hydrostatic equilibrium. That it is about a round shape, nearly round shape, not exactly round shape, but nearly round shape. And the third condition is that it has cleared the neighborhood around the orbit, around its orbit. So now Pluto has not cleared the neighborhood. Pluto doesn't have a clear neighborhood. There are Kuiper belt objects also. Along with Pluto, what happens is when the Pluto is revolving, all right, when the Pluto is revolving, what happens is that sometimes it is closer to the sun as compared to Neptune. So that is why, because Pluto has not cleared the neighborhood, it has been now placed into category of dwarf planets. Now these are the three conditions. Now please remember, planet. What is a planet? Planet satisfies. A planet will be one that will satisfy all three conditions. If it satisfies all three conditions, it will be called as planet. If it satisfies only two conditions, the first two conditions, if it satisfies only first two conditions, what are first two conditions? The first two condition is it is in orbit around the sun and has a sufficient mass. If it is satisfying only two conditions, first two conditions, it will be called as a dwarf planet. And if it is only satisfying on one condition, it will be called as triple SB. What is triple SB? Small solar system body. It will be small solar system body, and this triple SB will be, which will be satisfying only first condition, which satisfies only first condition and not the second and third. And in small solar system bodies, we have meteors. All right. Sorry, not meteors. Meteors will not be there. We have comets as well as asteroids. Meteors are not in around the orbit. Just a second. It is not meteors. Only the comets as well as we'll have the comets and asteroids. So comets and asteroids, they become the small solar system bodies because they are in the orbit around the sun, but they do not have sufficient mass and they have not cleared the neighborhood. So these three conditions were laid down. Any celestial object which is satisfying all three conditions, is in orbit around the sun, has sufficient mass, cleared the neighborhood, it is a planet. If it satisfies only two conditions, in orbit around the sun, sufficient mass, then it is a dwarf planet. Satisfies only one condition, in orbit around the sun, it is a small solar system body. Now these are the planets, some of the information about the planets. This is all about the factual information. However, there are certain concepts also, or there are certain reasons also, reasonable justifications also, so that you have to remember. Mercury, which is also the name that was given to Mercury because it is name of the Roman god of speed. It is the nearest and the smallest planet of the solar system. It is the nearest to the sun, and it has a cratered surface just like moon. As you must be seeing in this picture, in the supporting picture, you must be wondering that why I have placed a moon's picture here. But actually this is not moon's picture, it is the picture of the Mercury. It has the maximum diurnal temperature. It has the maximum diurnal temperature. Now what is a diurnal temperature? Diurnal means daily. And when we are talking about range, diurnal means daily and range means maximum minus minimum. Alright, when we highest temperature minus minimum temperature, that gives us the range. So when we are talking about the maximum diurnal range of the temperature, that means the days are very, very hot and the nights are very, very cold. So daytime the temperature can reach, or it can reach 430 degrees Celsius, and the night time the temperature is about minus 180 degrees. So what will be the range of temperature? What will be the range of temperature? It will be somewhere to the degrees of 620 degrees. Alright, 430. If we will calculate the diurnal range of temperature, how you will calculate the diurnal range of temperature? Maximum is 430. 430 minus 430 minus 180. Alright, and that will give you the range of temperature. Okay. Alright. And there is no atmosphere. Mercury as well has a thin atmosphere. Alright. And the exosphere is mainly composed of oxygen, sodium, hydrogen, helium, and potassium. The revolution is 88 days. That is, it is nearest. So, of course, the revolution will be fastest because it will be revolving. We'll understand this using the Kepler's law of motion. So revolution is the fastest for the Mercury. All right. Next is, when we are talking about Venus, it is also called as Earth's twin planet, and it is the hottest planet. Why it is the hottest planet? Now you must have seen that there are certain questions which are based on assertion and reasoning. All right, we have assertion, A type of statement, then we have reasoning, R type of statement, and then we have different options. So such type of questions you can, you can find such type of statements in these type of questions. Like Venus is the hottest planet. Reason, its atmosphere mainly consists of carbon dioxide. So then the reason is the correct reason of assertion. Because it is the hottest planet. Why it is the hottest? Because its atmosphere consists mainly of carbon dioxide. Now carbon dioxide is basically a greenhouse gas. What is a carbon dioxide? It is a greenhouse gas, and being a greenhouse gas, it absorbs radiation. What it does is, it absorbs radiation, and when it absorbs radiation, it increases the temperature. And that is why it is the hottest planet and not the Mercury, because Mercury, the night temperature is very, very less. It is also the brightest object in the sky. Alright, the brightest object. Why it is the brightest object? Again, why is important for such type of questions? It is brightest object because of the highest albedo. Alright, it is brightest object in the night sky or in the sky after sun and moon because of highest albedo. And why it has highest albedo? Because it has the clouds of sulfuric acid. Now, what is albedo? This is a new term that you must have encountered today. What is albedo? Albedo is nothing but it is the amount of sunlight reflected without absorption. So without absorbing the amount of sunlight that is getting reflected, that is called as albedo. Like for example, you must have seen that the soldiers who go in the Leh, Kargil, Siachen, they wear heavy or very, very wide glasses or goggles. Why? Because snow has highest albedo. Snow, it reflects light, sunlight directly without absorption. So that is the albedo. What is albedo? It is amount of sunlight that is reflected without any absorption. There is also phosphine was found in the Venus outer atmosphere, which is a possible indicator of the microbial life, and also it is called as morning or evening star. Now wherever in the planets you find US at the last, alright, Venus, Uranus, these are the two planets, and you'll see US at the end. Venus and Uranus are two planets which do not revolve or rotate, sorry, not revolve. They do not revolve as the other planets. They revolve in the opposite direction. So the Venus, it rotates, not revolve, it rotates from east to west. That is in the opposite direction, and its rotation is the slowest. That is 243 days it takes, and revolution is 225 days. So it completes revolution in 225 days, but the rotation takes 243 days. Or you can say that a year at Venus is it is less as compared to a daytime. All right, the day is bigger than a year on the Venus. It also has no satellite. All right, in the same manner, because it's now about time, we have it's 1:30. So we'll complete the rest of the planets in the next session, and we'll also talk about the evolution of the Earth as well as the Earth, the geological time scale. I'll share the PPT, the PDF in the group, in the geography group that we have. All right. So with this note, we'll take leave after. If you have any doubts, I'll take your doubts. All right. So please write down your doubts if you have any doubt. If you have any doubts till now, and alternatively, you can unmute yourself and you can tell me if you have any doubts. Tell me. Any doubts, anyone? None? All right. So we will keep it up to this in today's session, and we'll meet again tomorrow at the same time, and we'll complete the planets, as well as we'll talk about the Kepler's law of motion initially, and then we will move forward to the Earth, and we'll understand the formation of the Earth, the evolution of the Earth, and please, go through this thing. Your we have the just a second. Let me stop the sharing. All right. So we have this thing. Your physical geography book. So in your physical geography book, just go through the chapter 1 and the chapter 2 of unit 1 that is there, that relates to universe, galaxies, as well as the solar system. All right. So that would be all. Thank you. Bye bye. Take care. Jai Hind. If you have any doubts, you can post it in the chat group also. If you are seeing this at the afterwards, so you can post it in the chat group. That's it. All right. Thank you. Bye bye. Take care.